Today we are going to solve problem 24 of IIT JAM MS 2023. Let us begin with the question. Here it is told that AN is a sequence such that the first term A1 is equal to 1 and the recursion relation given is 4AN plus 1 equal to root over of 45 plus 16AN, wherein is running from 1 to infinity. Then which of the following is true? Whether AN is monotonically increasing and converges to 17 by 8, whether AN is monotonically increasing and converges to 9 by 4, where AN is bounded by 17 by 8, or whether series AN is convergent. Now let us begin with the solution part. So we have the sequence AN such that A1 equal to 1 and the recursion relation is given by this quantity. So for n equals to 1, we can have the value of A2 as 61 by 4, which is approximately equal to 1.95, which is greater than 1. Hence we can assume that AN plus 1 is greater than AN. Now to apply the induction procedure, we need to show that AN plus 2 is greater than AN plus 1. To prove this result, we apply the induction procedure. So using this recursion relation, we get that 4AN plus 2 is equal to 45 plus 16 AN plus 1, which is greater than root 45 plus 16 AN, which is nothing but 4AN plus 1. This follows from our assumption that is AN plus 1 is greater than AN. Hence we have proved that AN plus 2 is greater than AN plus 1 for all n greater than equal to 1. So by the method of induction, we can say that AN plus 1 is greater than AN for all n equal to 1 to infinity. That is, AN is a monotonically increasing sequence. Now we suppose that AN converges to a limit and let it be L. Suppose AN converges to L as n tends to infinity. Then solving the equation using the tail property of sequence, we get the value of L as 16 plus minus 56 by 32. Now since A1, which is the first term of the sequence, is 1, which is a positive quantity, so our limit should also be a positive quantity. Hence we are not considering a negative loop. So L turns out to be 16 plus 56 by 32, which is 9 by 4. Hence we get that the sequence AN converges to 9 by 4. And it is monotonically increasing. So option B is correct in this case. So for this question, option B is correct, that is AN is monotonically increasing and converges to 9 by 4. I hope you liked the problem.
Hello guys, welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and entrance examinations in statistics and data science like IIT JAM MS, ISIM Stat and CMIMS data science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT JAM MS, ISIM Stat and CMIMS data science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Today we are going to solve problem 25 of IIT JAM MS 2023. So we are given the two series. We need to check the nature of both the series. So let us proceed to the solution part. Here we are given the series S as n running from 0 to infinity AN, where AN is this quantity. To apply the ratio test, we need to calculate the quantity n plus 1 by n, which turns out to be 3n plus 5 by 4n plus 5, which tends to 3 by 4 as n tends to infinity, which is less than 1. Hence by the ratio test we can say that the series S is convergent. Now let us proceed to see the nature of the series T. Series T can be written as summation n running from 1 to infinity un, where un is the quantity nth term of this series 1 plus 1 by n whole to the power minus n square. To apply the root test, Let us calculate the quantity limit n tends to infinity un to the power 1 by n, which tends to 1 by e, which is less than 1 as n tends to infinity. Hence, by a root test, we can say that series T is also convergent. Hence, from both the standard results of root test and ratios test, we can say that both the series S and T are convergent. So option C is correct in this case. So for this question, option C, that is both S and T are convergent.